recording is going to be on oxidation reduction. Oxidation reduction is when there is an exchange of electrons in a reaction. One chemical gets oxidized and the other gets reduced. And to remember what's happening with the electrons, you can remember oil rig. Oxidation is loss of electrons, reduction is gain of electrons. Remember, electrons are negative, so if you gain them, you become more negative, so reduction in charge. Okay, you have to know oxidation numbers in order to figure out if something was oxidized or reduced. Remember, anything in its elemental form is 0, so aluminum, with no charge written on it, has oxidation number of 0. But don't forget your diatomic molecules. Have no fear of ice cold beverages. So all of those, even though it says H2, N2, F2, those are still elemental forms, so they get an oxidation number of 0 as well. So either how it looks on the periodic table or one of these diatomics. If it's a monoatomic ion, meaning that it's an ion with only one element, the oxidation number is the same as the charge. Pretty easy. If you're talking about a molecule or complex ion, there's a few rules you have to follow. Always base the charges off of the most electronegative atom, meaning closest to fluorine. Okay. The oxidation number of hydrogen is usually +1, but sneaky hydrogen can sometimes be -1 if it is bound to a metal, so be careful of that. The other rules are, if you have a neutral compound, the sum of the oxidation numbers have to equal 0, so when they add up, it must be 0. And then if it's a polyatomic ion, yes, you must still know those. The sum of the oxidation number is the charge of the ion. So if you have NH4 plus 1, which is of the ammonium ion, the oxidation numbers have to add up to +1. So let's do some practice. All right, look, sulfur, elemental form, oxidation number 0. Magnesium, it's an ion, +2. F2, yes, it has a 2, but this is not a molecule. We're going to still call this an element. It's a diatomic, so oxidation number 0. H2O, I'm curious about the oxidation number of oxygen. Well, we have to compare. Is hydrogen or oxygen more electronegative? Oxygen, definitely, so we'll give it its ionic charge, -2. This time I want to know about iron. Well, chlorine is more electronegative, so we have to base it off of chlorine. Chlorine, as an ion, holds a -1 charge, but we have 2 of them, so that's a total charge of -2. In order for this to be a, yes, neutral molecule, we have to add a +2 in, so iron's oxidation number is +2. Here we have iron again, but is its oxidation number going to be +2? Let's see. It's Fe2O3. Again, we're going to base it off of oxygen times 3, though. -2 times 3 is a -6. We have 2 irons to cancel out this -6 charge. So what's -6 divided by 2? Or actually, we should say +6 divided by 2. It's a +3. So remember that your transition metals can be multivalent, meaning they can have different charges, different oxidation numbers. Carbon here is the same thing, except for now we have a polyatomic, so it's carbonate. It has a -2 charge overall. We're still going to base it off of oxygen, so that's -6. But now, whatever the oxidation number of carbon has to add to -6 and still leave you a -2. So how about a +4? So again, it's just math. You can practice the rest. All right, so oxidation reduction reactions happen simultaneously. As one is losing an electron, the other chemical is gaining it. So we have what's called 2 half reactions, and we can put them together to make a full reaction. You must balance them, and to balance them, you have to balance electrons. Okay? Everything is about the transfer of electrons. So here we have silver going from a +1 oxidation number to 0. And iron is going from a +2 oxidation number to a +3. Remember your oil rig. So silver is having a reduction in charge. So it's reduction, and then iron is being oxidized. Its charge is increasing. In order to balance, we're going to write these two with the arrow lined up and count out our electrons. All right, so take a look. Silver, in order to go from +1 to 0, has to add in 1 electron. Iron, to go from +2 to +3, has to lose 1 electron. So we are talking about the gain and loss of 1 electron. It cancels out. So when we write the overall reaction, it's already balanced. We don't have to change any coefficients. And there you go. All right, let's look at one more example. So magnesium is going from an oxidation number of 0 to a +2. That must mean it's being oxidized. And aluminum is going from a +3 to 0, so it's being reduced. Now, let's rewrite the two half reactions and see if our electrons are balanced. Hey, look, they're not. Okay, so aluminum, to go from +3 to 0, must gain 3 electrons. Magnesium, to go from 0 to +2, must lose 2 electrons. Well, in order for this reaction to happen simultaneously, we have to have the same number of electrons lost and gained. So we must multiply by a coefficient. So if we multiply the top reaction by 3, we get 6 electrons. If we multiply the bottom reaction by 2, we also get 6 electrons. They cancel out, and we can write our final overall net ionic equation. All right, so that is oxidation reduction. Study.